Okay, I am making this little video just to go over the calculating molar volume portion of today's lab activity. So we already talked about the calculations, and on number 6, you just need to compare your experimental value, which is what you determined here in number 5, with your theoretical value, which is what we determined up here in number 2. So with calculating molar volume, what we want to do is, first off, we need to remember that 1 mole of a gas is always equal to 22.4 liters of that gas at standard temperature and pressure. And remember, STP is 273 Kelvin and 1 atmosphere. Okay, so then it says using the measure of volume, pressure, and temperature of the hydrogen you collected in this experiment, determine the volume of hydrogen of your hydrogen at standard temperature and pressure. So what if we changed from the conditions that we had in the lab today to standard temperature and pressure, to these conditions? Okay, so we're going to use the combined gas law for that. So we have P1 V1 over T1 equals P2 V2 over T2. Okay, and we're going to rearrange that setup to solve for V2 because you measured your initial volume V1, that's what you measured in the lab. P1 is what we calculated back in number 3. T1 is what we measured in the lab when we turned our Celsius temperature into Kelvin. And so we're just going to put, and P2 is our 1 atmosphere and T2 is our 273 K. So we're just going to rearrange that and solve for V2. And an easy way to do that, which is kind of one of the reasons I wanted to make this video, is to make sure we understand that when we're doing combined gas law, one of the easier ways to solve for the variable looking for is what we call cross multiply and divide. Okay, so because essentially you've set up 2 proportions. So we're going to cross multiply and divide, which if I do that, that gives me P1 V1 T2 equals P2 V2 T1. And so then if we're solving for V2, we're going to divide both sides by P2 V1. T1. Okay, and that's how we're going to get V2 by itself. And then we know all of these numbers. P1, remember that's what you calculated up there in number 3, the pressure of your hydrogen gas. V1 is the volume that you measured in liters. T2 is 273 Kelvin. P2 is 1 atmosphere. And P1 is the temperature, the Kelvin temperature of the room. So we found the Celsius temperature with the thermometer, and then we add 273 to it. All right. That gives you your new volume. So number 3, using the volume at STP that you calculated above, convert to liters, and divide by the number of moles of hydrogen produced. That's going to give us our molar volume. So I'm just going to make up a number here. So let's say that after I plug all of that in, my V2 is 40 no, hang on. Our V2 is, 0.042 liters. Okay, so what I'm going to do then is 0.042 liters, and I'm going to divide by the number of moles of hydrogen that I have. So the number of moles of hydrogen that were produced, remember we found that up there in number, where did we find that? Hang on. I think I'm missing a question or something. Because I know we found that. Okay. Well, I think I have a different version of it. But anyway, so let's erase this. So to find the number of moles of hydrogen that you produced, remember that's where we're going to use where we use PV equals nRT, and I know I explained that in class. So the pressure that you had of the hydrogen, the volume of hydrogen which you measured, and then T is the temperature of the room, and then R, remember R is the gas constant, 0.0821. 0.0821 liter atmospheres per mole Kelvin. Okay. And then you're going to rearrange that equation to solve for N, the number of moles. So to do that, we're going to divide both sides by RT. So N is going to equal our pressure times our volume divided by the gas constant times time. And that tells us our number of moles. And that's what we would divide our volume by. So again, let's say our volume was 0.042 liters. And let's say that our, let's say that when we calculated that, and again, I'm making up a number right now, so you would use the number from your data table and plug in and solve for the actual, get the actual number there. So let's say that let's say that we had 0.924 moles. Okay, so if we divide those two things out, then that means our molar volume, our liters per mole, would be 0.042 divided by 0.924, which is 0.045 liters per mole. And then we can turn that into milliliters per mole if we multiply by 1,000. And then we'd calculate our percent error. We compare that to what it should be. So this number is not right. Like I said, I made up that number. That's a bad number to use. Say that comes out to be 2 moles. There we go. So if I have 2 moles of hydrogen, I divide that into my volume of 0.042 liters. That means I get 0.021 liters per mole, which is 21 milliliters. Okay. And then I want to compare that to the molar volume constant at standard temperature and pressure, which is 22.4 milliliters in 1 mole. Okay, so we take our volume, we divide it by our moles. Let's say our moles is 0.002 moles. That's how much hydrogen gas we produced when we used the ideal gas law and we solved for N. So 0.042 divided by 0.002, that gives us 21 liters per mole. I cannot write tonight. There we go. Okay, and then I'm going to compare that and get a percent error comparing to 22.4 milliliters, 22.4 liters. So the actual value, 22.4, minus your calculated value divided by the actual value times 100. And that's how we get our percent error. So 22.4 minus 21 divided by 22.4 times 100. We are 6.25% off. So that's how you would calculate the percent error there. Okay. I just wanted to go over that in a video real quick. You will need to go ahead and answer after you get done with number 3. You do have to answer all 10 of these or however many questions are on the post lab, the actual handout that you were given in class. Okay. So remember, again, to do number 3, the first thing you have to use is ideal gas law to find the number of moles of hydrogen that you produced at your conditions. And then you're going to compare that to molar volume, which is 22.4 liters per mole at standard temperature and pressure. Okay. All right. Check Schoology for the due date for this, and then we talk about it in class a little bit, but you do need to have these calculations done before then.